Okay, hello. Welcome to BEEMAN livestream BLS003. Today we're gonna look at adding Prisma to a NestJS API. I had a few issues with Streamlabs OBS and my sound, so I'm trying out a new application called Live, which causes this little icon here. And I'm gonna see if this stops blowing up my machine. Now, I'm gonna get started anytime now. And what we're gonna do today, let me share the screen. And what we're gonna do today is look at Prisma. And for those of you who are not aware, Prisma is a database layer for TypeScript and Node.js. It's not an ORM, but it seems to fulfill a very similar role. And the way that Prisma works is it allows you to define a schema like this. And in this schema, you define your models, which can have relationships. And then in the schema, you also provide the data source and the client. And this client is what you'll actually end up using in your Node.js system. Now, Prisma can also generate clients for Go and for Rust, if I recall correctly, but we'll be using it with JavaScript. So the goal of today's live stream is to install Prisma globally, initialize a new project, look at the schema, maybe adjust it a little bit, and then we need to figure out what to do with the database. So let me up the voice a little bit because let me know if this is better for my voice. So we're gonna look at the database. We're gonna install Postgres and Docker-Compose and run some migrations. Well, let's see where we're going with this. The first thing to do is follow this guide. So what I'm gonna do is install Prisma.DEV. I'm gonna install at Prisma CLI, and I'm gonna install it inside the BEEHIVE project that we've been working on in the previous sessions. So I'm gonna say yarn add -d Prisma CLI. And now this will add a dependency to our project, and it will install the Prisma CLI. And while that's running, I'm gonna quickly check the resources on my machine. Keep an eye on that, so I know when I need to have some fill-ups, but it looks like this Live works pretty decent. So I'm glad that those issues are over. So with that out of the way, we now have Prisma installed globally, and the next step following the tutorial is to initialize the project. So we're going to say npx prisma init, and this will create a Prisma folder inside our application. So it creates the file schema.prisma inside the Prisma folder. So let's take a look here in the editor, prisma.schema. And here we go. This is the empty schema file that's generated, and you see we don't have any models. So let's hop back to the documentation and see how we can define our model. So here in the Prisma schema tab, the data source and the generator are defined. So this is where the data is being stored. This is what's being generated by Prisma, and then this is the model definition. So let's here be lazy and just do whatever they did here. So I'm gonna start out, let me copy over these entries. I'm gonna start out with a new model called user, and inside this user I'm gonna define the ID field and the created at field. Schema has a specific domain-specific language. It has their own language, and it's, as you see, it's not really anything that looks very complicated. Let's create some more properties here. So on the user object, let's say email, so they can log in, which is a string. And let's say passwords, which is also a string. Now with this schema, we can actually run a migration that will transform this model to the database. But in order to do that, we need to have a database first. And I don't have one running right here, but what we can do is in Docker, if you have Docker running, create a docker-compose file. docker-compose.yml. And we're going to paste in this snippet here, and I'll share it with you in the link in the description down below if you're watching this on YouTube. This is a pretty standard Docker compose where we define one service called Postgres, which pulls the latest Postgres image. It opens on port 5432 and it sets some environment variables, and these are the ones that we need in a little bit to connect our Prisma client here, our Prisma data source, to this database. Now another thing to note here is that in volumes I define a mapping to the volume var_lib PostgreSQL data inside the container. And my local mapping is current folder tmp/Postgres. And the way I do this is because this makes it super easy to nuke your database later on. So it will generate it here in the temp folder once it starts. It actually has one started. Let's get rid of it. It will generate it right here. And once you want to get rid of your data and you want to have a clean start, you can simply go into TMP and nuke this folder. So I highly recommend you checking this out. So when we do docker compose up, it will start a new instance of this Postgres container, and because we just nuked the database, it initializes from 0. So it's running its bootstrap script, and in a little bit we should get the message that this is ready to go. Then on the Prisma side of things, so if we look at our Git status, we see that we have our Prisma file here, our package.json and yarn log, and the Docker compose. So this is where we're at right now. And because we have this Prisma file in place, the schema.prisma in the Prisma folder, we can say npx prisma migrate. And migration works in a few steps. You first save the migration, which will save it to disk, and you will then run it, and that will apply these changes on disk to the database. So what we're going to do right now, we're going to give this migration a name, going to call it init, and going to create it if not exists -c, and we're going to pass in the experimental flag. Prisma migrate is still experimental, so this is something that's not, they put this under this flag in the CLI, and this is the way to run it. So once we run this, I need to update my database settings. Let's do that here in prisma.env. This is where we have the database settings. Let's change this because we have Prisma as a username and as a password and as a database. And then the schema public, I'm fine with that. So let's run this again. Prisma migrate save. And what we should see now is that inside the Prisma folder we have a migrations folder, and inside that folder it created the migration of this change. It even creates a markdown file where it lists down the changes. So if you would push this to Git, and we can do this in a little bit, this is something you could see in the pull request. So you can see in the pull request which changes are made to the data model. So let's switch to a branch here and call this one add Prisma just for good measures. And we're gonna add everything except the no, let's not do it for now. Let's not bother with doing a commit. We'll do a commit in the end and go over that. So next to this file being created here, it also created a migrations table in the database. So database migrations are being kept track of at two places, one of them being the file system here and the other one being the database where you sync it to. And it's important that you keep these two in sync. And we'll touch on that later. But for now, this one is generated. So what we can do is say npm, npx prisma migrate up and pass in the experimental flag again. And what this did is run this migration inside the database. So it had one create table statement, and this table is now created. And if we would look with a database tool at the database, we would see that this data is actually there. But for now, we can believe that this is how it works and just trust on that. So we ran the migration, and next thing we're going to do in order to work with this client is say npx prisma generate. Now let's keep an eye on node modules here, because this will be used to generate the actual Prisma client. So the Prisma client here is now being generated. I first need to download it. That shouldn't take too long. And once this is downloaded, it will create a client here in node modules. This is the Prisma client that it needs. And now it's generated. And it generated in node modules at Prisma client. So if we take a look here, we'll see we have at Prisma client. And what this actually does is a link to the .prisma folder, and this is where our code is being generated. So it's this code that we'll be using in Node.js to do our actually database queries. And it's strongly typed, and we'll see how it works in a little bit. But the idea is that we can simply import something from at Prisma client, and we can use it to access the database. Now bear in mind, if you update something in your schema, you have to do the Prisma migrate, the Prisma up, and the Prisma generate. So what I tend to do is add a little script here in node modules, in package.json, add a script in package.json. Let me get this one here, package.json. And what I tend to do is add a script, Prisma migrate and Prisma generate, and run these two together when I say Prisma apply. So I first want to run the migrate. After that, I want to run the generate when I execute this one. Now the generate one is fairly straightforward, which is just npx prisma generate. I need to pass in any flags. The migration we do in 2 steps. So we do the migrate save. Let's copy over this one. And after that, we do the Prisma migrate up. Let's copy over this one. Prisma migrate up. There you go. And if we now run Prisma apply, it will migrate a new client and generate it for you. Now let's see what that looks like. So we're gonna stage our changes here. We're not gonna commit it quite yet, but in our schema file, what I want to do is add first name and last name fields. So right here, let's call this one first name and last name. And I don't want these to be required. So I can pass in a question mark here, and this will mark these properties as not being required, similarly to how you mark things optional in TypeScript. Now what we want to do, we see that this is the change we made in the schema, and we're going to say yarn prisma apply, and this will run the 2 commands for us. And if all goes well, if I didn't make any mistakes in the schema, which it looks like I did not, it generated a new Prisma client for me. If we go to node modules and we look inside this Prisma, we should now see a reference of first name here. There you go. So this is the workflow you have with Prisma, and this is basically what it does for you next to actually executing the queries, which is of course important as well. But from a development point of view, this is what you need to know, handling actually the Prisma schema and reapplying those changes. Now let's look at how we're going to use this inside of our project. So on a quick look here, we can see the differences in the schema Prisma, which are the 2 these two fields. And then in this migrations now, we see that we have a new migration here. And we can see in the preview of the markdown here that these are the things that are being added. So this is quite a useful tool if you want to have, if you have a production application and you're basing on this on, you're basically dependent on migrations to make sure that your database get changes, get in the project the way you want it. Now let's create a commit here and say add new Prisma project. Husky run cannot be found. Let's make sure that we have all the dependencies installed. Now in order to use this, what I like to do is create a data library with NX. And inside that data library, I'm going to define a data service. And this is the service that I'm using to actually fetch data. And this is a nice clean way to wrap around Prisma, which is probably a good idea because their API will change and you can build your own little layer on top of it. You'll probably leak some of their internals, but I think it's nice to have at least one place where you can create some common layer above Prisma. So let's see if the commit works right now. Husky seems to be found. Perfect. Okay, so next thing up is NX generate a nest library that's called data. And this will create a data library for us. And as I did with the previous one, this is something that we need to register in our app module. Or is it? I don't think we do. Let's do it for good measures anyway. I'm quite indecisive today. I didn't really practice a lot. I'm sorry, folks. I'm just getting started. Hey there, Mr. Zach DeRose. It's so nice to see you here, man. I thought about when I'm going to invite you. I'm not still not sure when, but I will invite you soon, Zach. And I thought about having a thematic day, special guest Saturday. So I started off with Open Source Sunday, and I think it's nice to have like special guest Saturday, something like this. So yeah, you can expect an invite anytime soon, and we can do some fun stuff on stream. So it got created, the data module got created. So if I now import it here, we see that it gets imported from BEEHIVE data, but of course TypeScript is out of sync. So let's restart the API. And once that's started, we can start creating our service. So let's move into here and actually go into this folder and create the file data.service.ts. Now we're gonna work, let's see if this, restart TypeScript, so there you go. This is all found, and we should see that the data module is being loaded here. Great. So in our data service, we're gonna export, I'm sorry, gonna export data service, and we're gonna make this one injectable. And let me take a look at my notes here, because I got a peek notes here. What this service is going to do, we're going to extend the Prisma Client. Now the Prisma Client is what gets generated in this at prisma/client package. And this way we basically extend it. So anytime we now inject this data service, we have access to everything that the Prisma Client does, but we have some nice space to add custom logic. And we'll see a little bit about that in a bit. Now in case what we need to do to properly extend the Prisma Client is call super. So another thing that we're going to do here is implement a few interfaces, and let me make this a little bit bigger for you all. And we're going to be implementing on module init and on module destroy. And these are two lifecycle hooks that are provided by NestJS Common. So we're going to implement these members, and in in the onModule destroy, we're gonna say, let's make this async, this dot $disconnect. And in the onModule init, we're gonna say, await this dot $connect. And let's get rid of this typing for now, because it doesn't really give us a whole lot. But basically we connect and disconnect to the database. So let's see if that works. Well, in order to make that work, we need to provide it in the module. So let's go here to providers and call DataService. There you go. And let's see, API seems to start no errors here at all, so that's good. And now we can take a quick look at how we can actually use this stuff. So let's say we want to have a create user method, and we want to take an email as a string. Let's pop in an object all at once, an email, which is a string. And password. Oh, need to make TypeScript happy here. So we have a create method, and we fetch, we take an email and a password. Now this is what we want to store to our database. So what we can do is call into this.user. Now remember, this is provided because we extend the Prisma client here. This.user.create. And in here we can pass in a data object and set our properties. So we can say, okay, email and password. And there you go. Now this is an asynchronous operation, so we need to await it and make this method async. And what we can do is basically get the new user. So let's get created user and log out our created user. Now with this method in place, let's create our admin user and just say this create user, pass in email admin@example.com, password secret 123, and if all is correct, we should be able to, there you go, see our user being created. So this record now lives in the database, and it also gives us a nice starting point because we have our first user. If we now want to create content, we can just say, okay, pass user ID 1 to it, and have you go. So let's comment out this one for a second, because this is quite a common pattern, I think, that we want to create an admin user inside this, inside our APIs. So what we can actually do is onModule init after the connection is say await and create or ensure admin user method. And now what this ensure admin user method goes to do is check if we have an admin. If not, create it for us. So that seems like a useful thing, and the way we can actually check if we have an admin user, if we have our admin user, is to find if we have a user with a certain email address. So let's say we create a method async find user by email, pass in the email, and return this dot user dot find one, and add a where statement here. Now, as you can see, where here only takes an ID, and this is because email is not a unique property, whereas ID is. And in Prisma, if you want to do a where statement and figure out a single object of a collection, of a table, you need to pass in only one of the unique fields. So let's go over our Prisma schema. And in this schema, add the add unique decorator. Now let's run Prisma apply again. This runs the generation for us. It asks us if there's potential data loss. We're going to say we're all right with that, because we know we have only one entry. And now if we look at the regenerated service here, we can click into here. We can see that we now actually have an input that also asks for email. So this is a very useful way to say we just want to find a user with this email, right? Now let's make this a bit better yet. Let's default admin, create a default admin property here and give it the values, email and password that we just used, so we can actually use this default admin property right here. So what we want to say is const existing, or const found is probably a better way, is await this.findUser by .email, this.default admin.email. Now this allows us, this should give us back an email. Now then, if we have an email, we can say, okay, log out. Let's use the NestJS logger. Logger.log admin user and pass in, show us the email address and give this a context data service. So if we found a user, it will log it out and will return true. If not, we're going to say await this dot create user and pass in this dot default admin, and then add a message admin user created admin user created dot, and I'm sure we need to return this one. So let's this one just return. We weren't returning this, so we were logging it out here. Let's properly do this. Create user returns an object, and this one uses the created value. So now when we save this, we should see here that we have an admin user found. There you go, admin user example.com. And if we were to remove this database from TMP here, it would get recreated with these properties. Now let's see how we're doing with time. We're half an hour in, so let's go. We have some time left. I feel that this is a nice opportunity to use the environment here and say admin email and admin password, and add these two to our dot example. And now, instead of having these properties here hard-coded, we're going to make these two being read from our env file. So let's get rid of these quotes here. And what we then need to do is go to our configuration. Say that we have an admin object here, which has, let's see, an email, which is process.env.admin email. Yep. And the password, which is admin password. So that's in place. We can now ask for this, and in our validation schema, we're gonna also add admin email and password, and both of them are join.string.required. And can we do email? Yeah, we can say it's an email. So admin email also must be an email. So let's save this. It will rerun the validation. Now, what we want to make sure is that we're actually getting a hold of this data that we passed here in env. So inside our constructor, let's inject the private read-only config, which is the config service from NestJS config. And in here say this.config.get admin. and log this one out. So this should give us the admin props, the admin data that we set inside our application module, inside our .env. There you go. And we can now use this to assign it to default admin. So we can say this.default admin dot get is this.config dot admin, and basically get rid of this one and strictly type it where we say we have an email of type string and we have a password of type string. There you go. So this all looks pretty well, I'd say. And we have a nice added benefit that we can, we have automatically admin being created if it's not there, so that's nice. And if we want to now add content, we can at least give it an owner, which is good as well. This is generally something we're interested in doing, associate data to a user. So first things first, let's look at the data that's changed. I'm gonna add it all. So we're gonna see that we got the whole library data was created. We updated validation and configuration in the core. We loaded our data module and we updated our env and env example. We also updated the Prisma schema and we told it to make email unique so we can query on that easily. So let's call this implement data module. Implement data module. And there we go. And let me quickly tick off some of the things we need to do. So go, because I think it's time to actually start defining the models of our application. Now, for those of you that didn't check yesterday's application, let's take a quick peek at what we built. We built a GraphQL API and we added the courses and course module queries, and we added create course, update course, delete course, and some things to associate lessons on these courses. So if we look at the shape of these courses, this is actually super similar to the Prisma data model. So let's copy over course here. Let's open the model again. The schema, I should say. Let's open the schema again and change this word type to model and get rid of the semicolons. And if you look at it right now, you can see that we have actually valid information here, a valid object based on the type GraphQL output. So another item that we want to have is lesson. So lesson, let's take a look at the shape here. Lesson is ID, title, description, and content. So ID, title, description, and content. Now make sure that we're doing the same stuff in both places. So from a course we can, let's see, it looks like these are all, these are all optional. Now in the database we do want to have ID and title always being provided. However, description and image URL can be optional, and the same goes for lesson. Description and content might be empty. Title and ID should always be there. And let's make this auto-generated integers, both of them. So do some fancy stuff with formatting. Prisma can actually do this for you. There's a Prisma format option that we might want to use. Let's actually check it out, because I don't use it often enough. npx Prisma format. And this formatted the things. And actually, I should use this more often because it's pretty cool. Because what you can do with the Prisma formatting, you can say I have lessons here. And that is lessons array. And I think, no, it's the other way around. This is when I would do it imperatively, manually. I can define it manually. But what I can do, I can go to the lesson ID. I can say course, of type course, which is related to us by a course ID of type string. And then I need to to decorate this, and I always need to peek in an example, so let's quickly look at the documentation here. The relation. So what we can do here is define the relation. So we pass in a relationship with fields and references. Fields, the fields that this relation is being stored, in our case, is course ID. It's the one here. So let's update that. Course ID. And the reference field, so on the remote object, on the remote model, is ID, which is this ID. Now another thing we need to do is change course ID here to string, because the ID type here is string. Now this is all nice and good, and if we would run yarn prisma apply, this would get generated. But this relationship now is only accessible from one side. Only lesson can go to course, and we most likely want to use it the other way around as well. So once we run Prisma format, I think it should generate this reverse relation for us. There you go. It says lesson is an array of lesson. Now I like, per convention, I like to call this one lessons because it's an array, and this is the way to go, I'd say. Now with this, we have a course and a lesson model in our database. It's being generated. Let's run Prisma apply one more time. And once this is generated, we can use it. So let's go and do so. Inside our course service, what we have currently is a hard-coded list of items, right? And what we want to do here is define the constructor and inject data service. Now, in order to satisfy NestJS dependency injection, we need to open the course module, imports DataModule, and in the DataModule we need to actually export our data service. If not, TypeScript will get furious. With this out of the way, it should be fine though. There you go, server seems to be loading. And what we now can do is get a list of courses. So let's change this returning this.items to this.data.course.findMany. And let's see, let's take a look why this is not happy. This is not happy because I strongly typed it. Yes, let's get rid of this for a second. And this.data.courses.findMany will now call into our data service into the Prisma client and call the findMany method on it. So let's go here and get rid of the docs and run the query courses. And as a result, get the ID and the title. Now, course is an empty array because our database is empty, so that makes sense. So let's wire up create courses, create course, and we're going to pass a title, first course in DB. Now, inside and let's take ID and title here as well. I was looking at why it was red, but it was just not valid. Then inside our service, in the create course, we were doing all this work here, but what we can now do is say return this.data.course.create. Pass in an object with a data model and with a data object with a data key, and add here the title, which we're going to get from input.title, the description, which we're going to get from input description, and what more are we getting? Let's image URL, input.image URL. Now, because this course input object is actually the same shape as this one, we can simply say data is a destructured input object, and this should keep TypeScript happy. So this is the only thing we now have to do, and this will create the user and return it. So let's hit save, and then once the API is restarted, switch back to the API. That goes fast, I like it. Create it here, and we see that we have an ID created with 1. And let's create the second course in the DB, second course in the DB, awesome. If we now go here to courses, we see we have 2 courses. So far, so good. So let's quickly go over a more simple one. Let's first do delete. So delete simply returns this.data.prisma, sorry, this.data.course.delete, and delete takes a where statement and lists any unique values. Now, one of the things that goes wrong here is that we considered our API having IDs being a string, and in Prisma we define this as being a number or an int. So let's change this to being number, and let's for now get rid of this one because we don't need it anyway. Now, one thing we need to change though is that we had delete course return a boolean, and right now this delete option will actually delete, it will actually return the deleted object. As you can see here right above the cursor, it returns Prisma course client with course. So this is not what we want. So let's say const deleted is await this data course delete, and then return whether or not we have a deleted value returned back. And this should give us the behavior we had before, where we say, okay, delete a course, and then first time we delete it, we get back a true, and the second time delete it, we get back a false. So this is what we want. Now, make this part happy, where we say, okay, you know, ID is just going to be a number. So this restarts the server. We're going to reload our GraphQL server here, and we're going to name these mutations. Just going to have a create course mutation. Going to add a delete course mutation. These will get handy in the future, but for now, let's just delete one. First time we should true, second time we get an error. Okay, good enough for now. I'm totally happy. I'm going to leave this as is. So we need two more methods to change. First one is get a single course. So let's see, we have courses here, courses, which is plural. We only get back one. Let's get course singular in. Course singular, and here we pass in an ID. Well, we're going to pass in one. It says string cannot represent a non-string value. Well, let's fix this. Go back into the course here and say, okay, whatever ID you're getting in here is a number. This will break the this.course, so let's change the signature. Oh, let's do it manually. Change this to an ID, to a number, I'm sorry. And this should, yes, okay. This is still looking at items, so let's change this one. This should just go to this.data.course.find1, where ID is equal to the ID there. And now what goes wrong is that this course return object is no longer value. It returns a different shape than this course. For starts, it returns a promise, but I think these are not compatible types. Nah. Let's go with this because it's good enough. So this should give us the ability to get individual courses. And if we click this and we see we don't have a course with 0, we do have a course with 1. Other way around, we do have a course with 2, we don't have a course with 1. Now what I would like to see for this particular one, for this particular get one single course, I don't like to have a null. I'd rather instruct the user that we have one or that we don't have one. So let's see, let's await this call, return it here, make the method async, but if not found, we're gonna throw a new not found exception, course with ID not found. And then that should give us course with ID 1 not found, and on 2 we say course 2. Awesome sauce. So last thing we need to look at is update our method, and it seems that update our update course method. So in the resolver, when we look at update course, we still pass in a string. So let's change this one to a number. Let's go into our update course method here, change this one to a number. Now this.course, calling into this.course is still valid. The added benefit of doing it this way is that we get for free the not found exception. So if we want to update a course that doesn't exist, this method will actually be thrown and we'll get the same error message. So this is kind of a nice way to loop these things around. Now for the updated course, let's not try and be busy with the lessons, because this was a temporary hack, being able to update lessons and course all at once. Let's just say that you're going to return this.data. Oh, let's first make this await this one. This.data.course.update, and update takes two properties, a where and the data. So where ID is course.id, and change the data. I'm gonna just see if I can destructure input again. Now this works with if you have simple properties. If you just have strings, destructuring input into data will work. If you have more complex items in your DTO, like an array of string, for instance, you need to be careful, and you need to basically manually explicitly define those exceptions where it's not a simple type. Now let's take a look. Our course resolver is happy. TypeScript is no longer bugging. There are some things here. Let's not worry about it too much for now. Let's fix that in a second. What we should be able to do is say mutation update course, and update course takes an ID. The course we want to update, we say I'm going to update to, and it takes an input, which is an object with a property title, but we're going to say description, updated description. And as a return, we want to see the ID, the title, and the description of the course. Now the reason this is still red, I believe, is because it expects a string. If we refresh our playground, the schema is updated. And this should now work. We see the updated description, and we can say another update. So, as you can see, we were able to change our database with Prisma, like our in-memory database with Prisma, like in about 20 minutes. And I think that is kind of exciting. I think it's quite exciting. I love working with Prisma. So let's go over our lessons, because these need to be updated as well. So in the lesson resolver, first thing, the obvious thing we can do is change course ID, which is no longer a string. Course ID is now just a number. And then we have to update the create lesson method here and change course ID to be a number. Sorry, number. And we have to await this.course, and that needs us to make create lesson async. Now, what we actually want to do is create a lesson for this course. So let's get rid of the old here and say return this.data.lesson.create. Now, as we've seen before, create takes a data object where we can see data, and here we can connect our course to the ID of the course that we found. So what we need to do here, we say the data we want to pass, the data we want to create our lesson with, takes the data we want to create our lesson with takes a course, and this course is going to be connected, and we're going to connect it through the ID property, where ID equals course.id. Now we need some more properties, because data also needs a title. So we're going to say lesson also needs a title, input the title. And you know what? We can probably just, again, destructure input, and that totally works. So create lesson should now work as well. Let's create a new tab here. Or is this? No, this works. So what we're going to say, mutation is create lesson. And create lesson takes a course ID, which in our case is 2, and it takes an input, which is an object, and this object has a title, new lesson for course 2, and let's take the ID and the title from this create lesson. Quickly refresh to make sure it's valid, and it looks to be valid, and there you go, we have a new lesson for lesson 2. Now previously what we could do is go here in courses and just ask for lessons and then say lessons ID and title, and when we do this right now we see that lessons is null. This is because the endpoint we're calling into here does not fetch the relationship with lessons. Luckily this is super easy using Prisma. So in our courses endpoint here, in our find_many call, we're going to add an object and say include, which in turn takes an object, and say lessons equal true. And this will create the queries for us that also includes the lessons. And when we now hit this one, we see that the lessons get applied. This is something that has been a huge improvement from Prisma 2 over Prisma 1. Prisma 1 didn't allow this kind of includes, Prisma 2 does, and it cleaned up a whole lot of code. So cool, let's go to the lesson resolver one more time, and in the lesson resolver look at what we did with updating a lesson. Now in our previous structure we kind of needed to ask the course ID in the lesson because we couldn't just ask for the lesson by ID. However, with our proper database in place we can get rid of this course ID property, and this lesson property we're going to change this to a number, and in here going to get rid of course ID, change it with a number. Now let's look at this cleanup. What we actually want to do for update a lesson is say this.data.lesson.update, where ID is lesson ID and the data is the destructured input object, and we can get rid of everything that's here. So quick test while this server is being restarted. Mutation, update lesson, and say lesson ID is 1, which is this lesson we just created, and say input title. Let's give it a description. Added description to lesson 1. Now in the return type we're going to add for the ID, the title and the description. And once we run this we see that the description got now added, just as expected, and if we go here it's added as well. There you go, very good. Let's create a new lesson, temp lesson for course 2. We have a temporary lesson, and now make sure we can delete this one. So last thing to fix here is the delete lesson option. So for the delete lesson we also no longer need course ID, and the lesson ID can be a number. Get rid of course ID here. Get rid of course ID here. Lesson ID number, and then let's quickly peek at how I did deletion here. Yep, it's gonna do the same thing. So I'm gonna say const deleted. Let's get rid of this all. Const deleted is await this.data.lesson.delete, where ID equals lesson ID, and return whether or not we have a deleted returned. And then this should make our TypeScript happy. I still see a... yes, I got an error here from ESLint that says that I'm not correctly importing this from the data service, and that's correct. I'm doing a deep import here, and what I should do is do a clean import just the way it should be. In order to do this, I go to the data module and say export the data service. And this is what gives this option to change it to BEEHIVE data, and now I'm getting data service from the nice correct place. Some more TypeScript complaints. Items is now obsolete. That's good, because that That means we completely made our in-memory database obsolete and we replaced it totally with Prisma. And let's get rid of the course because we no longer need it. Switch back to the lesson here, and I want to delete mutation, delete lesson, and delete lesson takes an ID, and we're going to get rid of 2. First time, hey, lesson ID is 2. First time it's true, second time is false. Let's quickly fix this one. In the delete lessons, we're gonna first say const found equals this dot lesson. No, let's not bother. Let's not bother with the not found exception. But yeah, this is how you're gonna use Prisma in a NestJS API. As you've seen, it's super straightforward and simple to set up. So let's quickly loop over what we've done here. We're gonna first check what these changes are. So we had a bunch of migrations after we made changes, and we re-implemented or refactored the course resolvers, lesson resolvers, and the course service in order to use Prisma. So feature refactor course module. If I could only type refactor course module to use Prisma over in memory DB. Perfect, and that's up in GitHub in a few seconds. So what we did in today's stream, we looked at Prisma, prisma.io. I highly recommend you checking it out. It's a great toolkit. Documentation is pretty awesome. It's up to date. The team is very responsive. They're great people in general. And we used this to define our schema. We initialized it, we installed it, we initialized it. That created a schema for us. And we defined a simple user schema with course and lesson. Now, this schema generates for us a client that's here generated in Prisma Client. This is what we used in our data service right here. We ensured we had an admin user, and after that we updated our course service to make sure that we now use Prisma instead of the in-memory database we had in place. And with that, I'm gonna wrap up this live stream. Thank you so much for joining BEEMAN BLS003. It was great to have you in the place to be. Next up, we're probably gonna add authentication to this API, and then I think on Friday we're gonna look at rebuilding my website, BEEMAN.DEV. So go check it out how it looks right now. You can follow me on Twitter. You can follow me on YouTube, and actually I would really appreciate if you give me a like there, because with 100 likes I can get a vanity username. That would be kind of cool. So thank you very much, and I hope to see you all soon in BEEMAN BLS.